Hey guys, I thought I'd make a video about powering your microcontroller circuits. So normally when you power a PIC microcontroller circuit, you use a benchtop power supply or you may use a breadboard regulator which will allow you to supply the 5 volts or 3.3 volts required by your circuits. However, something you need to keep in mind is that a lot of PIC microcontroller circuits you will design may become battery powered, and one aspect that beginners usually overlook is voltage regulation in their circuits. Let's look at a ubiquitous 7805 voltage regulator. We'll see that this regulator can handle up to a 25 volt input and can supply up to 1.5 amps of current. However, what you may not realize is that the device itself consumes power to operate, and the quiescent current of this device is between 6 and 8 milliamps. To put that into perspective, a lot of PIC microcontrollers consume power down in the nanowatt range when sleeping. So while your MCU device may be sipping power, your voltage regulator will drain your batteries. The solution some persons turn to is to use a Zener diode. A Zener diode is a diode which functions as follows. When the Zener diode is reverse biased, which is to say the cathode is more positive than the anode, it breaks down at a voltage we call the Zener voltage. This does not destroy the diode, but provides a voltage we can use for reference or regulation purposes. While this Zener diode regulator circuit has the application, the quiescent current of such a device is quite high, usually heading into the tens of milliamps range. The solution to this problem is not only to examine the current output of your intended device, but also to look at the quiescent current as well. While the LM7805 will consume about 8 milliamps just being idle, an IC like the LP38500TS from Texas Instruments will consume about 15 microns of quiescent current. While it does have a low quiescent current, the maximum output of the IC is still limited to 1.5 amps. Up until now, the power supplies I've been discussing are what are known as linear power supplies. However, sometimes you do require a greater current output capacity, and you may need a drop-in replacement for your linear regulator device. When you require more power for your circuits, you can use what is known as a switch mode power supply. These are usually modules you can buy off the shelf. In later videos, we'll discuss how you can make your own. But for now, you can use the off-the-shelf modules when in their higher current output for your device. Ones like the one shown here are found everywhere and are very reliable. If, however, you already designed your board for an LM7805, a company called Raycom provides a drop-in switching regulator with about 95% efficiency that you can use in your designs. The R-78E devices don't require heatsink and consume about 1/8 less power than the LM7805 IC. At first, this seems like an amazing benefit, and you may wonder if switch mode power supply devices generally feature higher current output capabilities while having a lower quiescent current, then why would you bother out with linear regulators at all? Well, the answer lies in the data sheet. If we look at the R-78 data sheet, we'll see that there is an output ripple and noise associated with such devices. Due to the internal resonance properties of the internal components of such a device, a small fluctuating voltage is produced that creates noise in our circuits. While this may be fine for some circuits, others are sensitive to the noise produced and thus prefer the use of a linear power supply device. In a later video, we'll talk all about noise and go into depth on switch mode power supplies. In the meantime, what you can do is place what are known as decoupling capacitors on your regulator outputs. These are best kept close to the voltage pins of your IC, and a value of around 0.1 microfarads is fine for most applications. When used this way, these devices can eliminate most of the high-frequency noise typically associated with switch mode DC to DC converters. So that's it for this video, guys. Thanks for watching, and be sure to like and subscribe to my channel.